Hello. Hello. Thank you for coming. My name is Dmitry Pogrebnoy. I'm a team leader of RubyMine team in JetBrains. And today I will talk about Ruby debuggers. So we use Ruby debuggers quite a lot in our daily working process, and we will use them even more because of the code generated by AI, right? So with this pressure, we need to know our tools even better to stay productive. And in this talk, I will cover open source Ruby debuggers as well as RubyMine debugger. I've been working on RubyMine debugger for several years, and today it's a chance for me to share my experience and show you main concept of Ruby debuggers. So let's start. In this talk, I will cover 5 questions. First, we will take a look on the tools that we have to find bugs in Ruby code. After that, we will see what technologies power Ruby debuggers. Then I will show you how do Ruby debuggers work internally. And at the next step, we will see which debugger is the most performant. And at the last part, I will take a chance to show you 3 main features of RubyMine debugger that will help you work more productively. So let's start from the first question, and let's see what tools do we have to find bugs in Ruby code. And let's start with a simple example. So here we have a method process that takes 1 argument. Inside this method, we check whether an argument has toString or inspect methods. And if it's true, then we print element is printable. Otherwise, we print element is not printable. And here in the example, we have 2 calls at the bottom. The first call, process of 5, prints element is printable, as it should. But the second call looks pretty suspicious. It prints element is printable, but basic object doesn't have toString or inspect methods at all. And yeah, apparently there is a bug here in this code. So let's think for a second, and please raise your hand if you know where the problem is. Don't worry, I will not ask you about that. I will show you the right answer on the next slide. If you know where the problem is, raise your hand. Yep, great. So the real problem is here. This part goes as an argument to the defined method, and in this way, our method process print element is printable, regardless of the argument, even with nil. Yeah, this is a problem. We can fix it just by adding a couple of parentheses for the first part of the if condition, and after that, our output will be correct. This is a pretty simple example, right, with almost obvious bug. But what tools could we use to find real bugs in real Ruby code? And the first thing that comes in mind is put statement, right? So we can place several put statements here and there in our code, and they will give us some hints about where the problem is or what we need to do next to investigate our problem further. At the same time, we could use puts debugger gem that makes our output more distinguishable between each other. And also we could use awesome print gem that makes our output more structured and easy to read. Generally, put statements are really helpful, but they're too basic. And for something more advanced, we need a more complicated tool. And we have this tool. We have interactive consoles. In Ruby, we have mainly Ruby and Pry consoles, as you know. We still need to modify our source code to make them work. We need to place a call to a certain place in our code. And here, this tool is more advanced than puts debugger and put statements, but they still lack of one important feature, the lack of execution control and the lack of stepping. And the next tool, Ruby debugger, has all necessary features like stepping, breakpoints, context and frame introspection, everything we need. And this tool is the most advanced tool in Ruby ecosystem for investigating bugs in Ruby code. But before we start with debuggers, let's ask ourselves, how often do Ruby developers use a debugger? And the answer is here on the slide. So every 3rd run is a debug run, according to our stats in RubyMine. It means that Ruby debuggers as the crucial part of our development processes, and that's why I'm here. That's why I'm talking about Ruby debuggers. If we become more productive with debuggers, then we become more productive in our work every day. So let's move to the next step, and let's see what technologies power Ruby debuggers. The first technology is tracepoint. It was introduced a long time ago in Ruby 2.0, and it mainly provides an ability to execute some specific code on a certain event in your code at the runtime. It works almost everywhere. It works in threads, it works in fibers, but it doesn't work in Rector yet, unfortunately. And let me show you an example. How does it work? So here we have a method, say hello, and we have a tracepoint targeted to call events. At the bottom, we have a call of our method, and we have our output in comments. So as you can see, first we have a message from the tracepoint, and only after that we have a message from the method itself. Having only tracepoint, we can even create probably the simplest possible debugger in Ruby. And this part is the main difference from the previous example. So in this part, we take an input from the user, and we try to evaluate it, and we print the results to the console. In this way, we will be able to introspect the context on each call event. It means that we will be able to debug essentially every method invocation. And that looks so simple, right? So it's impossible to make it that simple without tracepoint. And that's why tracepoint is a crucial thing for any Ruby debugger. The next technology is Ruby virtual machine instruction sequence. Instruction sequence, in short, ISEQ, is essentially a representation of compiled bytecode for a Ruby virtual machine. It's tightly coupled to Ruby version, the virtual machine, and that's why it depends on the Ruby version. And this technology mainly provides an access to low-level representation of your Ruby code. So with this technology, you can modify your bytecode without touching the source code. In that way, you can adjust behavior, you can increase performance of your application, and other opportunities here. And let me show you an example how we can get instruction sequence of the method in Ruby code. So here we have the same method, say hello, with put statement, and then we take a method object from this method, and we pass that method object to instruction sequence method. At the end, we just call tsas method just to get human-readable representation of instruction sequence. And let's take a look at the result, right? So here what we have several lines, several instructions, and they're pretty readable. We can even read our argument for our puts statement. It's hello RubyKaigi 2025. That's great. And there is another one thing here. These marks represent events that will be emitted at the runtime at a certain instruction. And this is a way how instruction sequence collaborates with tracepoint. Tracepoint targets to these events at the runtime, and that's how they work together. So that's it about technologies. We have tracepoint and instruction sequence. And next, let's take a look at how Ruby debuggers work. And I would like to start with Debug Debugger. It's a well-known debugger. It has all necessary features, breakpoints, step-in, context introspection, everything that we need. It's default debugger for old Ruby and old Rails versions. It still requires modification to our source code to make it work. Usually we need to also place a call somewhere or configure our project to make it work. And by default, there is a command line interface for this tool, but you can fight a bit and configure VS Code plugin to work with graphical user interface. This is the main highlights, but how does Debug work, right? And this is a simple model of Debug Debugger. So all this code should be invoked before the code that we are going to debug. And at the top place, we have two lists, a list of breakpoints and list of tracepoints. In the list of trace points, you have a trace point per each event type. So one trace point for call event, one trace point for return event, and so on. And each trace point are essentially the same. They have the same body, the same code. In each trace point, we try to find a breakpoint at a certain place where we are. And if we find it, then we pass our control to the user. Otherwise, we just continue our execution without any additional steps till the next event. This approach works. It works reliably. It allows us to debug our code. But there is one issue. So we do a lot of unnecessary checks on each event to find our breakpoints at the runtime. And that's the main problem because it leads to performance degradation. And the next tool, Debug Gem, overcome this performance issue. But before we start with Debug Gem, let's take a look at the main feature that allows this debugger to overcome this performance issue. And this feature is trace point improvements. Trace point improvements were introduced in Ruby 2.6, and it mainly provides an ability to target our trace point to a certain line or even ISEC. In that way, we don't need to check every event for a breakpoint present. We can create a trace point, and we can target our trace point to a certain place where we have a breakpoint for sure. In this way, we don't need to do any unnecessary work, and that's why it works fast without any performance overhead. Let me show you an example. How does it work? Just to illustrate this feature. And here we have two methods, say hello and say goodbye. We have the same trace point as before, targeted to call events. And the difference is here. So we target our trace point to the ISEC of the first method. And at the bottom, we can see that our trace point was triggered only once for this first method and was ignored for the second one. That's the main feature. Well, Debug Gem uses this approach to overcome performance issue, and in fact, this debugger doesn't have any performance degradation, and that's a great achievement over by bug debugger. Also, this tool supports Ruby starting from 2.7 and greater, and it's mainly because the fact that trace point improvement wasn't ported to the previous versions, so only modern Ruby supported. Apart of that, there are several front ends for this debugger. You can use VS Code, you can use Chrome, so a couple options here. And the main thing that this debugger is bundled in Ruby starting from 3.1. And that means that this is a default option for debugging your code in the modern Ruby, especially if you don't have any other tool, like RubyMine Debugger. And that's it about open source Ruby debuggers. And let's take a look what RubyMine Debugger could offer. First, this debugger is bundled in RubyMine by default with graphical user interface tailored for developers' productivity. This debugger provides seamless debugging experience. For example, there is a feature that you can launch this debugger without any prior configuration, just in one click in the IDE. That's great. Apart of that, this tool supports Ruby starting from 2.3 and greater, so almost all possible Ruby that your application could use are supported. And with all these supported Ruby versions, this debugger works fast. So it works fast even with old Ruby. And last touch here is that there is an ability to attach this tool to any Ruby process. So you don't need to start and launch a debugger right from the start. You can attach this tool to already existing process when you really need it to debug. That's the main highlights. And yeah, how is RubyMine Debugger structured? And this is a general architecture of RubyMine Debugger. It contains three components. So the first part is debugger backend. Essentially, it's the base gem. It's responsible for low-level things like context and frame retrieving, manipulating with ISECs and trace points, and that's mainly a C extension. Then we have another component, debugger frontend, Ruby Debug IDE gem. This component is responsible for connection between RubyMine IDE and debugger itself, and for text representation of Ruby values that will be presented later in the RubyMine IDE. And the last part, RubyMine IDE itself. This component is mainly about user interface and developers' productivity, so almost all fancy features targeted to developers' productivity located there, and that's how it works in general. So this is a general architecture, but the real architecture looks a bit more complicated. So instead of one branch of gems, we have two branches. The first branch is targeted to call to alt Ruby, and it uses alt Ruby API. It contains several low-level hacks that helps us achieve desired performance. And it's really hard to maintain and add new features because of these hacks. So we decided to create another branch for modern Ruby. It uses modern Ruby API. It doesn't have any major hacks behind, and in that way, we are able to maintain and manage our debugger easily. So this is it about debuggers internals, and let's figure out which debugger is the most performant. To find this out, I created a simple experiment. We have Fibonacci method with a meaningless breakpoint that we never hit. And we need a meaningless breakpoint just to measure how a breakpoint could affect our debugger performance. Also, in this experiment, I used 100 runs just to get our results stable and reliable. And apart of that, I used all latest versions of Ruby debuggers available on the date. So we have two groups, for old Ruby and for modern Ruby. And as you can see, RubyMine debugger present in both of them, but with different sets of gem versions. And yeah, let's take a look at the results. Here they are. First, I would like to highlight that bug debugger works slow. It's more than 25 times slower than original run without any debugger. And at the same old Ruby, RubyMine debugger works fast without any visible performance issue. And that means that for the old Ruby, we have only one option to debug our code without debugger degradation. That's not really great because we have only one option for that, but we have a better case for the modern Ruby. In modern Ruby, we have debug gem and RubyMine debugger. They are both work fast without any performance issue. And in modern Ruby, we can choose what we need to use for each particular case. So now we know that debug gem and RubyMine debugger works fast. And let's move to the last part, and let me show you 3 unique features of RubyMine debugger that will help you work more productively. The first feature is debug Rails application in one click. Suppose we have a Rails application. It's really regular Rails application based on Puma server. And here on the screen, we have a config file for our Puma server. As you can see, we have 5 workers and 2 threads, right? So in that way, we deal with multi-thread, multi-process Rails application. And suppose we need to debug this application. Suppose we need to debug our method home in our controller, pretty usual scene. And first step we need to do is to add a breakpoint by one click on the gutter. Here it is. And after that, all we need to start our debugger is just one click on the debug button in the IDE, and that's it. After that, debugger will start, and we will be able to hit our breakpoint and see this view. So here we have list of frames, panel with variables and values, controls for navigation during the debugging process, execution console, and other things. And the feature is that we are able to launch our debugger without any prior configuration, without dealing with commands in terminal, without modifying our source code, just in one click. It works out of the box without any prior configuration, and it saves your time on that. Another feature is smart stepping. So suppose we have this example, this code. We have a class myPrinter with several printing methods, and we have a chain of calls at the bottom. So let's say we need to debug this chain of calls. So we put a breakpoint on this line. We started our debugger. We stopped on this line. And here we are. We need to debug this line. So how we do it in RubyMine? RubyMine Debugger provides several convenient actions for navigation during the debugging process. They called step enter, step out, and step over. And let's use them. So first, let's call step enter, and RubyMine provides us several options where we can actually step enter. And let's choose the second option, and let's step into our first method in the class. Here we are. Then suppose we investigated something here, and we would like to get back to our initial line where we were at the beginning. And for that purpose, we can call step out. And here we are on exactly the same line. That's impossible to achieve the same behavior with chain of calls with other debuggers. After that, we can repeat our actions. We can call step enter, and now we have two options here. Let's choose the first one, and let's step into our second method in the class. Suppose at that point we need to investigate something in this method in more details, and we need to step inside this method without going outside and without going deeper in the calls. So for that purpose, we can call step over, and in this way we can step inside the method. So last step is just to call step out and get back to our initial line where we were at the beginning. And that's how it works. It works reliably in simple cases. It works in complicated cases like chain of calls. And it saves your time on the navigation during the debugging process. So, and the last feature that I would like to show you today is inline debugger values. So suppose we have this example, this code. We have a method filter array that filters array in some way. It doesn't matter right now. And suppose we need to debug this method. We have a breakpoint on the line 4, and we launch our debugger. We stopped on this line, and here we are. In this view, we have panel with variables and values. And usually, during the debugging process, we need to match variables in the editor with values in this panel. So we need to go back and forth to make this kind of map in our mind, and it takes a lot of resources to keep it consistent. And yeah, that's not really efficient way. RubyMine provides a better solution. It provides these inline hints right in the editor. They show you variables and values near the place where variables are, right in the editor. With this feature, you don't need to go back and forth. You can see it right in place, and it saves your mind resources. That's it about features that I have today, and let's recap. So first, we discussed that Ruby debuggers mainly use trace point and instruction sequence. There are two core technologies for any Ruby debugger. Then we discussed that debug gem works fast due to trace point improvements, and that's a great achievement over payback debugger. And the last thing about RubyMine Debugger, it works fast with all supported Ruby versions. It provides one-click debugging experience for Rails application that saves your time on the configuration. It streamlines the debugging experience with smart stepping and helps you save your time on the navigation during the debugging process. And the last thing that it provides inline debugger values that helps you debug with pleasure and save your mind resources. So that's it. Please take your phones and scan this QR code to try RubyMine and RubyMine Debugger for free. Share your feedback with me on LinkedIn, and also we have a booth on this conference, so come to us to talk about Ruby, Rails, and RubyMine. That's it. Thank you.